Hi guys, welcome to my second tutorial playlist. In this playlist we will discuss how to make visualization of sorting algorithm in Python. The structure presents in this way. So first we'll discuss sorting algorithms. I will get into and explain how bubble sort works, selection sort, insertion sort, and merge sort. And then we will visualize actually how the sorting is done using tkinter module in Python and matplotlib. So let's kick things off with a bubble sort. Assume we have the following array: 3, 2, 1, 4, and 5. And how bubble sort works is we iterate through all of the list and we select 2 items from the list. So here we select 3 and 2, and then we compare them. 2 is smaller than 3, thus we push it to the left. Basically we swap places. Then we go on to the next numbers, we compare them and swap them, so we have 1 and 3. And we continue doing that. And we have our first iteration result, which is 2, 1, 3, 4, 5. Next, we repeat the process. 2 and 1 swap places, 2 and 3 is okay, 3, 4 as well, and 4 and 5 okay. And that's how we get the result. To implement bubble sort in Python, in our new file we will create a function of bubble sort, and we will pass an array that we want to sort in an argument of the function. We specify a variable that will store our length of our array, so it's easier to read in the code. And we go into the first loop. For I in range n-1. So what this loop will do is basically repeat the process n-1 times. So basically then we will be sure that our array is sorted already. Then we iterate, in each iteration we iterate through the whole array. So another for loop for j in range . And what this loop will do is iterate through our array until the second to last element, and it is because we will be looking at 2 elements. So we will look at jth element and j plus 1th element in our array. And now onto the comparison. So if our array of j element is larger than our j plus 1 element, then we just want to swap them. We can use the following syntax in Python, which is very neat. So we assign element j plus 1 to array element j, and the same with j plus 1 j. And perfect. So this would already work, and as we can see we can test it. So we can define our array, let's say like that, and we sort our array. So bubble sort our array, and then we can print it. We run the program and we can see it is sorted. However, in our example we could clearly see that we don't always need to iterate n-1 times through the array. And it is because we simply assume the worst case scenario here. So basically every iteration we will change something in the array. When it's not the case, we can basically return our function, so finish running the function. And to do that, we can create a new variable, let's say done swapping, and we initialize it false. And as soon as we swap, we set the array, the variable to true. And then in our for loop, if not swapped, done swapping. So if you are not done swapping, we can simply return. So basically, when we don't need to, when we didn't swap the array, we can return the function. And also we need to set the done swapping in for I in range, because every iteration we want to set it to false. And now when we run it, it's still sorted, but now it runs not as much times and it uses less resources. Moving on to a second sorting algorithm, which is selection sort. How this works is we select first number, which is 3 in our case, and then we iterate through all of the whole array and find the smallest number. So in our case it is 1, and then we swap places. So 1 and 3 swap places, and now we move on to the 2. So we select the 2, we find the smallest number in the array, which is in our case right now 2, so we leave the array as it is. And actually the same thing happens with 3, 4 and 5, which is our result. So once again, how the selection sort works is we select one number, we iterate through the whole array, and we find the smallest number. In our case, at first it was 1, so we swap them. Moving on to implementation of the selection sort in Python, we will do the same thing. So we will define the function, define selection sort, and we will also pass in our array. And now we do the same, so equals length of array, and we start our loop. Once again for I in range n, which does the same thing as in our bubble sort, and our second loop for j in range, and this time I plus 1 and our length of array. So why I plus 1? Because as we saw before in the explanation, if we have an array, let's say like this, we first select this and we, let's say we swap it like this, so the first elements get swapped, then we move on to the next one, and we only compare the rest of the array, so this part, and then when we move, we compare it to this part. So basically each iteration we will iterate through the elements that start 1 after the last iteration. We have to also keep track of our minimum value. We can do it by basically knowing the minimum index. So we can initialize our minimum I to I, and then we compare. So if array of minus I is larger than array of j, we set our minimum I to j. And as previously, we swap the elements of an array. So our array of I, array of min I equals array of min I dash array of I. So once again, what does the algorithm do? First we have the length of array, and then we iterate through the array n times, or n minus 1 n times. We initialize our minimum I, so we basically keep track of our minimum element in the rest of the array. So if we have an array of, let's say 1, 2, 3, 52 and 23, this loop will assure that our minimum I will be 2, so 0, 1, 2, and we just keep track of it in each iteration, and then we just swap the values. So we can try it out. Again, our array, let's say it's gonna be this time like that, and we do our selection sort on array, and we print our array. And we can see that it is indeed sorted. Moving on to the insertion sort, I'm gonna use an image from the website geeksforgeeks.com. It shows very well what the insertion sort does. So we have our array, and we iterate through it again, of course, and we basically see what values are correctly ordered in regards to our currently tested value. So we have 3, we check with only 4, which is larger, so we swap them. We basically push 3 to the beginning. We do the same with number 2. We push it. 10 is okay, 12 is okay, because all of the previous values are sorted correctly. So none of the values is larger than 12, nor 10. Then we move on to 1, and we can see that all of the values are larger than 1. So we put it to the beginning. We move on to 5, and we can see we go back. So 12 and 10 is larger than 5, but 4 is smaller than 5. So we insert 5 between 4 and 10. And we do the same for 6. We can see that 12 and 10 is larger than 6 and 5 smaller than 6. Then we insert it into here. To implement insertion sort, we define insertion sort. We pass again the array. We set the length of the array, and we begin our loops. First, for I in range 1 to n, which is basically again the same as here and here. Now we have to define our value that we'll be comparing to. So on our picture here, it will be the green values with a green background. So 3, 2, 10, 12, 1, 5, 6. We can do it simply by saying key equals array of I. And then we have to initialize our pointer in the array. So basically we will be jumping like, let's say we have our 5, and our variable will be pointing to the previous values. So 12, then to 10, then 4, then 3, then 2, then 1. And we will be comparing it with it. let's go j equals I minus 1, because we want to start at the index previous to the currently checked one. So we have 1, we will start at 12. And then while j is larger or equal to 0 and key is smaller than array of j, we want to swap the places. And also we want to put our pointer one place before again. So j, we have to subtract 1. So basically push our pointer backwards. And then we set the array of j plus I to our key. So we insert the value between the smaller and larger number. Just clearing up the code, and now we can test it again. We define our array, we call insertion sort on our array and print. We run it, and it is sorted. Next sorting algorithm is a merge sort. So in this, we split the array into left and right parts until basically we are left with single values. So this is the first step. So we have our array 3, 2, 1, 4, and 5. We split it in half. So we have 3, 2, 1, and 4 and 5. Then we split it again. So we have 3 and 2 and 1. And here it is 4 and 5. And we repeat after until we only have single values left in our groups. Then when we are split, we basically go from the end. So we have our split array, and we merge together the arrays in a sorted way. So we have our 3 and 2, we merge it, but 2 is smaller than 3, so we put it at first place. 1, we don't have anything to merge it with, but then we do the same with left and right. So 1 is smaller than 2, so we put it at the beginning. And 4 and 5, it is in a correct order, so we just merge 4 and 5 together. And then we merge 1, 2, 3, 4, and 5 together as well. Moving on to Python implementation, define merge sort of array, and now we have to specify the mid of the array. For that we will of course will have to define the length of array as n, and then we will specify the middle of the array. So mid equals n divided by 2. So it is basically a floor division. So for example, if we divide 15 divided by 2, it is 7.5. But when we floor divide it, we basically cut the point value. So it's just gonna be 7. Then we split the array into left and right ones. So in the following way, left is this and array as mid to the end. So this just tells us that we take everything until mid, and this is mid until the end. And then we will use the array in a recursive way. So basically we will call the function itself from the function. So merge sort of left and merge sort of right. We are doing it because, as we saw in the example, we want to split the array in half and keep doing that until we don't have anything to split anymore. So to do that, we initialize our variables I, j, and k to 0. They will be used later, you will see why. So while I is less than length of L and j is smaller than length of R, we have our if statement that basically compares left and right part of the array. Oh, not the first, but like this. And we assign our array of k to L of I. And we increment our pointer. If R is larger or equal to L, we select R instead of L array, so the right part is the proper one, and we increment the j index, and we increment k. So as you can see here, I is the basically the index of the left array, j is the index of the right array, and k is the index of our main array, so what we pass into the function. And now we have to check, as I said, because in our recursive algorithm we have to somehow know when to stop calling the functions, because otherwise it will simply run forever or throw an error. So while I is less than L, line of L, and then we assign L of I, so basically all of the leftover values, and k as well, and we do the same for the right array. Equals R of I of j, and we increment our j and k. Perfect. So this is the code for the merge sort. It is definitely the longest one, but we can test it now. So array is, let's say, like this. We perform merge sort of array, and we print it. So we have the error, which is recursion error. Yes, of course. So it happens because I'm not doing the check. So this is the problem that I told you, that we are basically running the recursion infinite amount of times, but we can fix it by adding if length of array. So if our n is larger than 1, we will only perform this, otherwise we will not. And we run it, and now you can see it is sorted. So thank you for watching our part 1, and part 2 will focus on visualization using tkinter and matplotlib.